All right, we're back to finish up the second part of the notes. And we're just going to jump right into the examples because we've already talked about the other ideas. Determine whether the events, we're right here, determine whether the events are independent or dependent, then find each probability. So what we have is tiles A, B, G, I, M, R, and S of a word game, so maybe it's Scrabble, are placed face down in the lid of the game. 2 tiles are chosen at random. Find each probability. Okay, so part 1 here, probability of drawing an R and then an S if no replacement occurs. Now remember, if we're not replacing, then these are dependent events. Probability of the first draw affects the probability of the second draw. However, if replacement occurs, then these are independent. Okay. So no replacement as opposed to replacement makes the difference between dependent and independent. So when we have the dependent, we're going to do the probability that we draw an R times the probability that we draw an S, given that we drew an R in the first draw. So let's look at what we have. We have the letters A, B, G, I, M, R. Only one of those is an R out of 2, 4, 6, 7 letters, right? 1, 2, 3, 4, 5, 6, 7 letters. So the probability of drawing the R is going to be 1/7. Okay, if we're not replacing, which we're not, probability that we draw an S, given that we drew an R, is now going to be 1 out of 6 because there's only one S, but there are 6 letters left. So that probability is going to be 1/42. And if you needed your answer as a decimal, you could just divide 1 by 42. Let's look at what that is. 1 divided by 42 is going to be 0.0238. Next digit's a 0, so we would round it here. If you need it as a percent, we would move the decimal point 2 places to the right and make it 2.38%. And that is our answer. Okay, part 2. Probability of A, then M, if replacement occurs. So this is now independent because we're replacing. So we'll do the probability of A times the probability of M. There's only one A in all 7 of them, so favorable is 1, total number of outcomes is 7. Probability of an M is also 1/7. And so what we will have is 1/49. 1 times 1 is 1, 7 times 7 is 49. This time I'm just going to leave my answer as a fraction and not take the time to change it to a decimal or a percent. Probability that we draw 2 consonants if replacement occurs. So this is again independent because we're doing replacement. Independent. And what we're looking at here is a consonant followed by another consonant. So we're not drawing 2 at the same time. We're drawing 1, replacing, and then drawing the second. But I want the probability that I draw 2 consonants. Okay? So probability of a consonant times the probability of a consonant. So that probability is going to be the same both times because we are replacing. So probability of a consonant is going to be, let's see how many of those are consonants. The B, 1, 2, 3, 4, 5 of them are consonants, right? So the number of favorable outcomes is 5 divided by the total number of outcomes, which is 7. And that's going to be the same for the second draw since we replaced first consonant before drawing the second tile. 5 times 5 is 25. 7 times 7 is 49. And we have our answer. Okay. Part 4. Now notice it says the probability of 2 consonants, but we're not replacing. No replacement. So now we have dependent events. Okay. So now we want the probability of a consonant in the first draw times the probability that we have a consonant given that we've already drawn a consonant in the first draw. Okay, the probability of a consonant is 5/7, but if I don't replace the first consonant, I now have 4 favorable outcomes, 4 consonants remaining out of the 6 tiles that are there. We're going to do a little bit of reducing. 5/7 times 2/3. We can't do any other reducing. 5 times 2 is 10. 7 times 3 is 21. And we have 10/21. And that's our probability. So almost a half, a little bit under half. Okay, part 5. Probability that we draw a vowel and then a consonant if no replacement occurs. This is going to be dependent. We're going to take the probability that the first one is a vowel times the probability that the second one is a consonant, given that the first one was a vowel. Okay, so probability of a vowel. There are 2 vowels in those 7 tiles. So 2 out of 7 is the probability that we draw a vowel. Favorable outcomes divided by total number of outcomes. And if we don't replace, then there are still 5 consonants, but only 6 remaining tiles. So 5 out of 6 for that probability. We can do a little bit of reducing. Let me write down one step here before I do the reducing. I can divide a 2 out of here and out of here. 1 times 5 is 5. 7 times 3 is 21. And we have 5 out of 21 for our probability. Okay, the last part of this example. Probability that you draw a vowel and then a consonant if replacement occurs. So the difference here is these are now independent because we're replacing the first tile before drawing the second. Let's do the probability that we have a vowel times the probability that we draw a consonant. Okay, and that's going to equal 2 out of 7 times 5 out of 7. 2 times 5 is 10. 7 times 7 is 49. And our probability is 10/49. And that is the end of that example. Okay, next thing we're going to do is talk about the addition rule of probability. So the addition rule of probability is for the or, the union. So the probability that an event A or event B, both occurring, A and B, or both, let's rewind. The probability of event A or event B, or both of those events happening, is given by the probability of A union B, because remember the union is the or. So we read that the probability of A or B, usually just read it that way. Probability of A or B equals the probability of A plus the probability of B minus the probability of both, right? We use the intersection for both. So you can use either one of these versions of the formula. They say the same thing. Union is the or, intersection is the and, or the both. Okay? We could have said probability of A and B right here. Okay? All right. So what's happening really is we have to take the probability of this plus the probability of this, but we've added this probability twice, so we have to subtract it back off. All right. So examples. A 12-sided die is rolled. Find each of the following probabilities. Notice it's 12-sided, not 6, 12. So our die has 12 sides. I'm going to list the numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so what's the probability that we have a less than 4 or a multiple of 5? So we're going to do this by doing the probability of less than 4 plus the probability that we have a multiple of 5. Minus the probability that we have both less than 4 and multiple of 5. So let's look at what happens. What's the probability of less than 4? Look at what we have. We have 3 out of the 12 that are less than 4. So that's 3/12. That probability is 3/12. Probability that we have a multiple of 5. Well, the only multiples of 5 in that list are 5 and 10, so that's 2 out of 12. But then we have to subtract the probability that we have both. But notice, none of our multiples of 5 are less than 4. So the probability that it's both is going to be 0. You can't both be less than 4 and a multiple of 5 at the same time. So we've got 3/12 plus 2/12, which is 5/12. We can add those fractions together easily because their denominators are the same. They're both denominators of 12. So add the numerators, keep the denominator as a 12. And we are finished. If you want to, or if you need to, you can change that to a fraction, or change that fraction to a decimal or a percent. Okay, this one, I'm just going to divide them here so we can see who's where. So this one, we're going to do the probability that it's greater than or equal to 7, plus the probability that it's odd, minus the probability of both. So if you're greater than or equal to 7, you're either 7, 8, 9, 10, 11, or 12. That's half of my numbers, right? 2, 4, 6 of the 12. Yep. So that probability is 6/12, plus the probability that it's odd. Half of those numbers are odd, right? 1, 3, 5, 7, 9, 11. That's 6 of them. So there's another 6/12. Probability of both. How many of my numbers are, both odd and greater than or equal to 7? So 7, 9, 11. That's 3 out of 12, right? Denominators are the same, so I can do 6 plus 6 is 12. 12 take away 3 is 9. And then we reduce that fraction. It comes down to 3/4, 3/4. So 75% chance of doing that. Okay, another way that you could do it, if you didn't want to use the addition rule of probability, you could actually just count the number of favorable outcomes and divide by the total number of outcomes, right? So how many are odd? 1, 3, 5, 7, 9, 11. But then add in or also count the ones that are greater than or equal to 7, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 out of 12, or 3/4. That gives you an option. Okay, part 3. I want to do the probability, remember this is the OR, probability of even plus the probability of prime minus the probability that it's both even and prime. Okay, so look at the evens. There are 6 out of the 12, so the probability that's even is half, 6 out of 12. Probability that it's prime, how many of those are prime? 2, 3, 5, 7, and 11. 5 of them, right? So 6 out of 12 plus 5 out of 12. Only one of those numbers is both even and prime. So we'll have to subtract a 1 out of 12. Probability that it's both even and prime is 1/12. Okay? Notice all of those fractions have the same denominator. So I can put them together. 6 plus 5 is 11. Take away 1 is 10. Put them together over that same denominator by adding and subtracting the numerators. Add and subtract the numerators, keep the denominator same, and we'll reduce that fraction to 5/6. So our answer is 5/6. Okay? All right, next example that we're going to do is going to involve a Venn diagram. All right, so the number of students in a high school is 1,400. Of those students, 550 take French, 700 take algebra, 400 take both French and algebra. We're going to fill in the Venn diagram, then we're going to find the probability that a student selected at random takes French or algebra. Or, notice the word or. Okay, this is 400 right here. 400 students take both. Okay, 550 take French, but I've already accounted for 400 of those 550, so that must be 150 right there. 700 take algebra. I've already got 400 of them that are doing both algebra and French, so that must be 300 right there. Now, to figure out how many don't take either one, we need to take our total number of students, which is 1,400, and we need to subtract the 150 that are taking only French, the 400 that are taking both, and the 300 that are taking just algebra. So if we subtract, what do we get there? 550. Okay. Now, we need to find the probability that a student takes French or algebra. Can I just use F for French and A for algebra? Probability of French or algebra. That's an or, so that we can use the addition property. That's the probability of French plus the probability of algebra minus the probability that they're taking both. All right, so what that's going to be, probability of French is going to be (550 over 1400). Probability that they take algebra is my 700 over 1400. I'm going to show you how to use the Venn diagram to do this in a minute. So probability of French, there are 550 out of the 1400 students taking French. So 550 out of 1400. Probability that a student is taking algebra is 700 over 1400. But then we have to subtract the probability that they're taking both, which is 400 out of 1400. Do the math there. 550 plus 700 is 1250. Take away 400 is 850. So we get 850 over 1400. We can reduce that fraction to 85 over 140. We can divide out a 5 from the numerator and a 5 from the denominator. We can leave our answer as a fraction, or if we want, we can change it to a decimal or percent. Let's see what it is as a percent. 17 divided by 28 is 60.71%. Now, another way that we could do this is we could look at the 150 plus the 400 plus the 300. That's 850. So out of our 1,400 students, the probability that a student selected at random takes French or algebra would be 850 out of 1,400. From the Venn diagram, we have 850 out of our total number of students taking French or algebra. So we could do it that way as well. We don't have to use the addition principle. I just wanted to show you how it worked, but we wouldn't have to use it that way. Okay, the last thing we're going to do, we're going to do a two-way table. So in this example, in Math Club, there are 34 students. 11 of the students are seniors, including 7 of the 20 who are short. 11 students are seniors. Including 7 of the 20. So I have 7 short seniors and 20 short students altogether. Student is chosen at random from the club. Fill in the table and find the following probabilities. Okay, so let's read through it carefully. Math Club has 34 total students. There we are. 11 of those students are seniors, so that's the total number of seniors. 7 of my seniors are short. 20 of my total students in the club are short. Right? 7 of the 20 are short. 11 of the students are seniors, including 7 of the 20 who are short. So that says I have 7 short seniors and 20 short students altogether. Okay, let's see if we can fill in the rest of the table. Yeah, we can. So in this column, that must be a 4 because the total has to be 11. In this bottom row, this must be a 23 to get a total of 34. 34 take away 11 is 23. 7 subtracted from 20 is 13. 13 subtracted from 20 is 10. And 4 and 10 add up to 14. That's also 34. Take away 20. Okay. Now we want to find the probability that a student is tall. So what that's going to be is 14 out of 34. Total number of tall students is 14. Total number of students is 34. Reduce the fraction to 7 over 17, and we are done. Probably that we have a senior chosen at random. So 11 of my 34 are seniors. So that probability is 11 out of 34. Remember, number of favorable outcomes divided by total number of outcomes. Okay, next one. This is an and. probability that the student chosen at random is tall and a senior. I'm going to do this without using the multiplication principle. I'm just going to use the numbers in the two-way table to save time here. So if it's tall, if the student is tall and a senior, that's 4. 4 favorable outcomes, right? They're tall and a senior. That's this number right here. Divided by the total number of students in my math club, that's 4 out of 34. We'll reduce that to 2 out of 17, and we are done. Okay? The probability that they're short or, oops, where did my, oh my heavens. I don't know how I did that. Sorry. Short or a non-senior. That's an or, right? We can either use the addition principle or we can just count it up in the table. I have how many short students? 20, right? Plus, here's my short students. There are 20. How many of those? Let's see. I need my other 10 non-seniors, right? So 20 plus 10. There are going to be 30 favorable outcomes from this. 30 divided by 34, which is 15 over 17. And that's our answer. We could also, let's work it out the other way. We could do the probability that the student is short plus the probability that they are a non-senior minus the probability that they're both. Let's see if that comes out the same way. So the probability that they're short, that's going to be 20 out of 34. Plus the probability that they're non-senior. I have 23 non-seniors out of the 34 students. Minus, there's my non-seniors, right? Total 23. Minus the probability that they're both short and a non-senior. That's 13 out of 34. So 20 plus 23 is 43. Take away 13 is 30. So we get 30 out of 34, which is 15 out of 17. Same answer we got before. Just wanted to show you both ways. Okay, that's the end of our video.